Today we're looking at the surface areas of pyramids and cones. Like the surface area and the lateral area of cylinders and prisms, these two things actually relate to each other in that they're the same formula, just that for cones having circle bases, we're going to have a set formula that will always work, whereas the regular pyramid, depending on the base, is a square or a hexagon or something else. Will change the way that we find certain parts of it, or possibly, right? So the 2/4 formulas that we need today would be if we have a regular pyramid, or if we have a regular cone. We have lateral area, which is just the area not including the base that we have. The lateral area of a pyramid is half the perimeter times the slant height, and we'll get to slant height here in a minute. The lateral area of a cone is 1/2 the perimeter, but the perimeter of a cone is 2 pi r, and half of 2 is 1, right? So we just have pi r l here. And then the surface area for each of these is, again, that lateral area. So you could just put LA here. I think it's better to have 1/2 PL again, plus, well, the area of the base, and that base can change, so we just call it B. B is for area of the base. And this would be pi r L, the lateral area, plus the area of the base. The base for a regular cone is always a circle. And the area of a circle is pi r squared. Right? So half of the perimeter times the slant height is pi r L for a cone, and the base is pi r squared. Right? Well, let's take a quick look at what this would look like. We'll do a pyramid, because it is a little bit tougher. Cone is fairly straightforward usually. So we're going to, and I'm just picking a spot, right? Notice I started with a parallelogram, and the back two sides here, the left side and the top side, being dashed. And that's just to give us the impression of a three-dimensional figure here. Right, not quite coming to the right point here. Our slant height is, since this is regular, that means a few different things. One is that all of the sides are the same. So even though they don't look like it here, the 4 sides of this pyramid are the same triangle, right? The base is a square. The slant height goes from the point here perpendicular to one of the sides here. So it can be on any of these. When we talk about slant height, this is the slant height. Right, so this is the slant height. It is the altitude or the height of one of the triangles, one of the sides, one of the lateral sides, right? The other then, though this isn't quite as important, if we drew an altitude, a height for the pyramid, right, it would be perpendicular, and it would go straight to the center of the base. So wherever the middle of the base, if we drew a circle around the regular figure where the center is, that's where it should go. And notice then that we have a few different ways that right triangles are being formed. You have a right triangle with the slant height, the edge of the pyramid, and half of one of the bases of the triangle here. Right, you have a right triangle. You also have a right triangle being formed with the height, the apothem, right, of the base, and the side here. Right, so a few different things that we should be able to notice about that's going on there. In a cone, it's basically the same. So the slant height will be from the, not too hard to draw, circle. Right, the slant height will just be this side here, but then you also have a height and obviously the radius. Right, again, cones are typically easier to work with because they keep the same formula every time. See, just a few other things. The ones that we're going to be dealing with are called right cones. So it has to form a right angle to the point here, and regular pyramids, which again do the same thing. If it's not a right cone, but it is a type of cone, like if it's pushed off to the side a little bit, that'd be called an oblique cone. And a non-right, non-regular pyramid is called non-regular. All right, just a couple of examples here then. First one will be a pyramid. Let's start here, if you're following along with me, a dashed line in the back, two solid lines coming forward, and then all of our lines going up can be solid. We'll draw in a slant height here. If it's helpful, you can do that one in a different color as well. It's going to be 20 centimeters. And since it is a regular pyramid, all of these sides are the same, and all of them are going to be 15 centimeters. So we want to find the lateral area. The lateral area is 1/2 the perimeter times the slant height. What's the perimeter of this cone? Well, it's a regular triangle as a base. Each is 45. 3 times 45 is 3 times 15 is 45, and we get half of 45 times the slant height. That's given here. The slant height is 20. Half of 20 is 10. 10 times 45 is 450. We are talking about area, so it's centimeters squared. Lateral area. Surface area is going to be that lateral area plus the area of the base. Right? What is the area of our base here? Well, it's a triangle, right? So there's actually two different ways we could find it. It's a right triangle. Sorry, it's not a right triangle. It is a regular triangle. And so we can draw in our height, and we can say, well, that's a right angle. This angle down here is 60. This one is 30. And since this is the hypotenuse, the short side down here is, again, half. Right, across from the 30-degree angle is half. And that must mean that this is 7.5 √3. Right? So the area of our base is 1/2 the base This is not the area of the base. When we say base here, we're talking about the base of the triangle, which is 15 times the height, 7.5 root 3. Now you could type that right in, which is probably what I would do. I put it off to the side here just to kind of show. So you could say this is 1/2 15 times 7.5 root 3. And just type that in and add them together. And I got 547.4. All right, if we look at another cone, another pyramid, this one we're going to do with a pentagon for a base. And you don't have to do perfect here. This is not, that's looking a whole lot more like I'm trying to do a regular hexagon, but that's fine. And I should have given myself more room. That back line should probably be dashed again. Not perfect, but will serve our need, or should serve our need here. So pop them 6 feet, side 8.7, and this one is still going to give us a slant height of 15. So our lateral area, oh, sorry about that. Pause if you didn't get it before. Lateral area is 1/2 the perimeter times the slant height. Perimeter is 5 times 8.7, which is 43.5. And our slant height is 15. Gives us about 326.25, but we're going to round up to 0.3 here because we're just going to go to the nearest tenth. But when we come back for surface area, if it's that close, going back and using the actual value is probably better. Plus the area of the base. The area of the base is 1/2 the apothem times the perimeter, right? This is a regular pentagon. The apothem is 6, and our perimeter is 43.5. And so we should just add that to it. And we get about 456.75. We'll round up to 0.8 feet. Again, make a note, if in the homework it asks you to round to the 100th, round to the 100th. That would have meant that we didn't round here at all. 326.25 and 456.75 would have been our exact answers. All right, looking at 2 cones, and then we'll be done. Cones, like I said, are typically easier because the areas of the bases always stay pi r squared, right? We don't have to go back and use 1/2 the apothem times the perimeter. did it again, I apologize. It is a right cone, 5 feet, and it has a 30-degree angle down here. Right? So what else do we care about here? We care about the slant height when finding the surface area. If you're wondering why we would ever need the height comes in helpful or is useful for us when we're trying to find area, right? But we're trying to find the surface area here, right? So what would be the slant height? Well, if we have a side of 5 across from the 30-degree angle, the side, the slant height here across from the 90-degree angle has to be 10 feet, right? The hypotenuse is twice the short side in a 30, 60, 90. And so our lateral area is pi RL. Radius is 5, slant height is 10. That gives us 50 pi. In a normal year, that is how I would have you give your answer. However, with the way things are this year, again, we are going to go 157.1 feet squared. Now, I would strongly suggest that when you come back for the surface area, you go back and use the 50 pi first. It'll give you a more exact answer here. And then we have pi r squared. R is 5, so that's 25 pi. And so we get 75 pi as an exact answer, or about 235.6 feet squared. All right, last example. We got 13 centimeters, and our height will be 12 centimeters. And again, it is a right cone. The question is, what is the radius? Hopefully you recognize this Pythagorean triple. Hypotenuse 13, one side 12, the other side is 5, right? A 5, 12, 13 Pythagorean triple. Probably the second most common Pythagorean triple we use, next to 3, 4, 5. And this might be a time that you would pause, try to do it all on your own, and then come back and see if you get it right. If not, you can just follow along. We get lateral area is pi RL. R is 5. Slant height is 13. We have 5 times 13 times pi. 50, 65 pi. Excuse me. Which is about 204.2 centimeters squared. And excuse me, surface area then is, then I would use 65 pi, not the rounded answer here, plus pi r squared. R is 5, square is 25, so we get 25 pi. That is 90 pi, and 90 pi is about 282.7 centimeters squared.